This is Josh White with JW Math Tutoring. In today's video, I'm going to cover 18 problems from the December 2025 Digital SAT Math exam. So let's go ahead and get right to it.
But life is a dream that calculus could never predict.
Before I start going through these problems from my December 2025 Digital SAT Math official problem set number 1, I just want to mention a few things. First, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, these problems were compiled from various sources, mostly Reddit, but from some other sources as well. So I've tried to recreate the problems to make them as realistic as possible. However, you may notice small differences between the problems that I have here on the worksheet versus a problem that you encountered on the official test, if you took it in December. So just keep in mind, you might see things like that. But like I said, I've tried to recreate them as best I could. Also, another thing just to be aware of is that if you may have a question that on the exam was multiple choice, but in this problem you see here, I'm doing as a free response question. So there could be other methods available to solve the questions that I'm not going to demonstrate because I'm not completing it as a multiple choice, but instead I'm doing it as a free response. So keep that in mind as well. Other things, there's only going to be one video with all the new questions, which is this video you're watching right now. The other video for December will have all the repeat questions, similar to what I did for October and November, where I briefly highlight the questions and show you what months and worksheet numbers to check out to see questions which are similar and or identical to those. Lastly, you have any questions or comments or concerns, please do leave them in the comments section below. And there'll be a link to the PDF file that has all these problems in it, both in the description of the video and in the pinned comment of the video. Oh, and one more thing too, if you haven't seen it already, my Excel and also PDF spreadsheet file, which has all of the questions from my official test problem sets going back to May of 2024, last year. Please check that out. There'll be a link to that both in the description and also in the pinned comment. That basically has every single question from these problem sets, the new questions. Brief description, main area, like main topic, a subtopic, shows which questions were repeated. It also in it has a tab which has links to all of the PDF files from the various, not the PDF files, excuse me, the videos, links to the YouTube videos from each month that videos were put out. So please check that out if you haven't done so already. All right, so with all that being said, let's go ahead and get started now. December 2025 Digital SAT Math official test problem set number 1. Okay, problem number 1, this circle problem. Very common problem that I saw come up. So first I will show you how to do this by hand, and then after that I will show you how to do the entire problem in Desmos. So first, to do this by hand, here is kind of the theory behind this. All right, essentially we're going to take the equation for circle A and we're going to complete the square on it. Now, really, we don't need to do that just yet. Really, all we're trying to do initially is get the coordinates of the center. I'm going to move the 4n over to the other side and put 2 blanks here. So, if you remember completing the square, we take the b term and we take half of it, and then notice that's -3, and then we square it, and that number is what goes in this blank and this blank. And then we do the same with the y's. B equals -10, cut it in half, -5, square it, 25, 25. Okay, I'm going to come back to this right side later. Now, if you notice what happens, this is going to factor as x minus 3 squared plus y minus 5 squared. And that's because when you do completing the square, essentially, it's going to factor as x and then plus basically the b over 2 term that you squared in the parentheses. Meaning here the b over 2 value is -3, so it's x minus 3. Here b over 2 is -5, so it's y minus 5. All right, what that tells us is the center of circle A is 3, 5. That means the center of circle B is also 3, 5. They have the same center. They do not have the same diameter or radius. So what I need to do now is calculate the radius of circle B. We don't need the diameter technically. Like it says the diameter of B is twice that of A. You can just replace this with radius, okay? Radius and diameter are both one-dimensional, lengths. Therefore, if one is twice the other, then the other will be twice, the other circle. All right, so now I can calculate the distance between the center of circle B and this given point that is on it. Now, I'll show you how to do this in Desmos during the Desmos solution, but let's just say you're going to, if you're going to draw this out by hand, right? 3, 5, it's like right here. 2 to the right, up to 5, 7, it's right here. So we're finding the distance from here to here, from 3, 5 to 5, 7. So notice it's basically just 2 to the right, up to 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. C squared equals 8. Therefore, c is equal to square root 8. So the radius of circle B, so this is the radius of B, is equal to the square root of 8. Notice, that is twice the radius of circle A. That means the radius of A will be half that value. It will be square root of 8 over 2. Now, you could simplify this. You could make this 2 root 2 over 2. And really, the radius of A just then simplifies to root 2. Okay, so now that we have that, well, that just means that in the standard form equation, r squared, or the radius squared, is root 2 squared, which is just going to equal 2. Thus, we now know that on the right side, this whole expression right here that I was doing for completing the square, this whole thing must equal 2. So 4n plus 9 plus 25 equals 2. 4n plus 34 equals 2. 4n equals negative 32. n equals negative 8. That is your correct answer. All right, let's see now how you could do this in Desmos. So I am going to go to Desmos. And the first thing I would do is I would type in the equation of circle A because I'm going to do some circle regression. By the way, if you want to know how to do circle regression, check out my Ultimate Desmos Guide to Digital SAT Math. I will put the thumbnail on the screen for the specific video which covers regression of circles. I believe it's in part 5, advanced functions, but the correct video thumbnail will be on the screen. So just give me 1 second to type this out. So what I'm doing here is I am regressing. Oh, I forgot to put the subscript 1. Okay, I'm taking equation of circle A and I'm regressing it from its given form to standard form. All right, couple things. This is not quite correct because I need to put element lists for x and x1 and y1. Once I do that, okay. Notice, it's auto-filling a value here for n. That's not the correct answer to the problem, obviously. That's just a random value it's filling in. So we can just ignore that for now. But the important thing here is getting h and k equal to 3. Okay, in other words, what we know is now the center of the circle, I'll just call this like capital C, is the point 3, 5. All right, so next, and one other thing just to show you too, let me just slide this up to cover the problem for a second. You can set n to whatever number you want. Like right here, I'm setting n equal, and notice as I move the slider, the h and k values do not change. Okay, even if I go into negatives, h and k are not changing at all. So the center values it finds for the coordinates for h and k are correct regardless of whether you pick the n value or whether regression picks the n value. Notice they're staying fixed at 3, 5. All right, so now let's just get rid of that and let's go back to the problem. So next step, we got the center. That was like step 1. Step 2, we needed to find the distance between the center and the point that's on circle B. So in other words, I am going to now, I'm just going to call this capital B for the point that's on the circle, and I'm going to find the distance between those two. Wait, I just defined this as letters, so I didn't have to type them all out. There we go. That is the distance between these 2 points, i.e., this is the radius of circle B. Now, remember, to get the radius of circle A, we have to divide this by 2, because the radius of B is twice that of A. Okay? Therefore, the radius of A will be half the radius of B. So I'm going to take this and divide it by 2. So right now I have this value is the radius of a circle A. So now all I have to do is I just have to set this equal to r, and that will feed this back into the original regression statement and find the value of n for this circle such that its radius is equal to this value, which if you recognize it, it is just the square root of 2. Boom. There we go. N is equal to -8, and that is your answer. That's how you could do this entire problem in Desmos and, in less than a minute. Again, basically all the steps, listed out here. All right, let's look at the next problem. So this is basically a sample size margin of error problem. Let me just also clean up some of this stuff so it's not distracting. All right, there's a wall of text here. The concept or the idea that you want to understand or want to memorize is that that there's an inverse relationship between sample size and margin of error. Meaning, as the sample size goes up, which is what's happening here, 30 is going up to 60, the margin of error will go down. So the margin of error will go down from 0.12 to some value less than that. Therefore, the correct answer for this one is A. And that's it. And the opposite also works too. If the sample size went down, if you selected fewer finches, then the margin of error would go up. Okay, so essentially the thing to remember is that margin of error and sample size, when you're talking about a survey, have an inverse relationship. One goes up, the other goes down. One goes down, the other goes up. All right, let's look at the next question, number 3. This is the saltwater solution question. It's basically just a linear function, with 2 variables here. And really, all you're doing is you're plugging in 40 for the x value, because x represents the number of gallons of a 10% solution. So if you have 40 gallons of the 10% solution, what is y going to equal? So we're just taking 0.10 times 40 plus 0.20y equals 0.18 times 40 plus y. Now I'm just going to go to Desmos to solve this. Delete this all out. I'm going to use regression. You can either type, if you want to keep it lowercase, you have to type y1, or you could use uppercase if you just don't want to bother typing the subscript. So let's do that this time. And I just said I was going to do regression, but I forgot to use the tilde. There's our correct answer. It is 160. That's how you could do this entire thing in Desmos. You could also technically type equals, but you'd have to use lowercase y, and then it would give you a horizontal line, all the way up at 160 as well. All right, let's go to the top of the next page. Here we have question number 4. We have a rational function. We're given 2 points. What is the value of b for this function? Which is a constant. A is a constant, b is a constant. Okay, so first I'll show you how to do this by hand, and then after that we will go straight to Desmos. So let's look at this first thing. Okay, you plug in -33 for x. So it's going to look like this. Let me fix this a little bit. Now technically, I'm still going to write this out, even though the bottom doesn't matter. And then this is equal to 0. Because if you're trying to solve this, say, for a, if you cross multiply, this whole thing times 0 is just 0. So really, we can just ignore the bottom for this, for this purpose. In other words, if you have a rational function and you have an x-intercept value. That's really what this is. It's the point negative 33 comma 0. It's an x-intercept. The denominator is irrelevant, when it comes to rational functions and finding x-intercept values. It's really where does the numerator equal 0. All right, in any case, with all that being said, you should end up with, let me look at my numbers here. Negative 33 squared. It should be 1122. No, sorry. Yes, 1122. Let's just do the calculation in Desmos. Because basically, you move the a over and you get a equals negative 33 squared minus negative 33, technically plus 33. Tilde negative 33 squared minus negative 33. Okay, so it is 1122. Now, to solve for b, we are going to use the second point. Technically, we need to solve for a in order to get b, because if we use the second point now and plug that in, notice it's like 0 squared minus 0 minus a over 0 cubed minus 0 minus b. Okay, and this is equal to 33. If you didn't know a, you couldn't solve this for b. So that's why we technically have to solve for a first, at least if I'm doing this by hand. So notice these zeros all drop out. So we get negative 33b equals negative 1122. I believe b should be equal to 34. Let's just double check though. Okay, close this out. Negative 1122 divided by negative 33. Yep, positive 34. So what is the value of b? It is 34. Correct answer is letter D. However, we could solve this entire thing in Desmos, so let's take a look at how to do that. Make a table. Let's put in my 2 points. Next, type a regression statement. Now the denominator, forgot to put the 1 here. What is b? b is 34. There's our answer. It also got the same a value that we got. That's how you do it in Desmos. Took me 30 seconds. All right, let's move on to the next problem. Question number 5. Clear off some of this stuff. Okay, so which of these functions below lies entirely in quadrants 1 and 2 when you graph it? So if you think about it, here's quadrant 1, here's quadrant 2. You basically need a horizontal line with a positive y value. Okay, this first one is diagonal. It's technically going to be like way up here at 39, and the slope is, ridiculously steep, but it's going to come down here and obviously go into quadrant 3. Not correct. 39x, same slope as the first one, but it goes through the origin, so it's going to be something like that. No. This letter C is going to be the correct answer. This is just y equals 39. It's way up here. It's a horizontal line. It's only in 1 and 2. And D is obviously wrong. That's going to be way down here at negative 39, quadrants 3 and 4. So the correct answer to this one is C. You could also just graph them out, and visually see it as well in Desmos. All right, let's go to the next one now. Number 6, bottom of the page. This problem deals with proportions, ratios. So you're told the ratio of cats to dogs is x to y. So we got cats on top, dogs on the bottom. All right, if there are 560 dogs, so 560 dogs in the house, which expression represents the number of cats? So let's just call this C for cats. So the quick, short, easy way to do this is just to notice, if you rearrange this, just multiply by 560 on both sides. The number of cats is equal to x 560, or we would just put this in front, 560x over y. Correct answer is letter C. Now, you could also use the strategy of picking numbers if it's too difficult for you to visualize or whatever with just all the letters everywhere in the variables. Let's do some picking numbers, okay? So let's say the ratio of cats to dogs is 1 to 2, okay? there are 560 dogs in the house, how many cats would there be? Well, basically, it would be half of 560. And if you don't know that, you can just, go to Desmos and figure it out. They're going to be 280. So therefore, notice, x is 1, y is 2 in my example. And now you would go to the answer choices and you would type in each answer choice looking for 280. So for the first one, okay, I'm going to use capitals just so I don't have to constantly type all the subscripts. And I'm also going to define, like, x is 1, y is 2. And again, we're looking for the answer choice that gives us 280. Okay, so 1 is obviously wrong. Let's look at, or not 1, A is wrong. Let's look at B, 560 xy. Okay, notice it gives me 1120, not 280. It's wrong. Let's look at this one. This C gives me 280. That appears to be correct. And let's just check out answer choice D, 0.0035. Yeah, it could completely wrong, not 280. So therefore, that just confirms the correct answer is letter C. That's an alternate approach that you could take on this problem. All right, top of the next page. This is a percentage question, and although I've done a bunch of advanced percentage questions previously, I just wanted to highlight this one because this one is actually a little bit easier than some of the other ones. It looks slightly different, but it's actually easier because there's only 2 constants in it instead of normally there's 3, like a, b, and c, or x, y, and z. So you really just have here the first equation, which is this decimal is now 0.09% would equal to 0.00, second, I need another 09, of multiplication times x. And then if you go ahead and solve this for x, you should get 128. So you can actually solve for x right away. Let's just confirm this. And also, I will show the Desmos, entire Desmos method after this. Okay, so we get 128. And now x, or 128, is 25%, 0.25, times a constant y. So y is just equal to 128 divided by 0.25, or 128 divided by a fourth. 512. Therefore, the correct answer for y is 512. That's what you would type in. Now, let's see how you could do this entire thing in Desmos. Let's get rid of this. Okay, so we've got a system of equations. Equation 1, 0.1152 is, so that's the entire left side. Now, so I'm just going to go to the right side, and what is it equal to? 0.09% of x. Here I'll use x1. Okay, now the second equation is, we know that x1 is equal to 25% of y1. Notice right there, gives me x1, it gives me y1. This is solving a system of equations using regression. If you are not familiar with this or do not know how to do this, please check out my Ultimate Desmos Guide to Digital SAT Math. I will put the thumbnail up on the screen for the specific video in the playlist that shows you how to do this. All right, next up, we have question number 8. This is the one about amount of time spent at a hotel pool. Basically, in March, it was T hours. Then in April, it was 3.60 T hours. Number of hours spent at the pool increased by what percentage? Okay, so percentage increase, if you just want to look at it, calculating it that way, it's basically just, new minus old over old times 100%. I mean, percentage increase or decrease, depending on which way the value is going. So here, it's just 3.60 T minus T over T times 100%. On the top, you get 2.60 T over T. Well, the T's just cancel out. Therefore, you get 2.60 times 100. It is 260%. The correct answer for this one is letter C. Now, You could also think about this kind of backwards if you're used to instead, doing percentage problems that way. And so what I mean is, you start with t and you add some quantity to it, right? And then you end up at 3.60t. So what did you add if you have 1 of something and you add a quantity and you get 3.6 of that? What did you add to it? Well, you had to add 2.60. I mean, you can just subtract, right, to find the difference. So this is the increase. 2.60 is the increase. And then so you just take the number 2.60, convert it to a percentage, times 100. That's how you get 260%. Okay? You could also technically go to Desmos and you could just do the percent increase calculation in Desmos. So like 3.60t minus t, new minus old, divided by old, times 100. We don't need to put the percentage, right? And notice now if I add a slider for t, it's 260%. Doesn't matter what the value of t is, right? Whether I move it, I mean, negative wouldn't make sense, obviously, so it's got to be positive, because time is always positive. But wherever I slide it, the percent increase is fixed at 260. So that just confirms that's the correct answer. All right, let's look now at the bottom of the page. Question number 9, this extremely long guinea pig survey design problem. Okay, so you can read all the text there. I'm not going to bother like reading all this text out. Basically, you're choosing some guinea pigs and some other type of rodent or animal from different habitats, and they study them, and they notice basically two things: that in early adolescence, the cavies, I don't even know what that is, were moved more across more squares than the guinea pigs. And it also found, but that's between like a between species comparison. Then it also found for both species, comparing like early adolescence to late adolescence, the virtual squares decreased, meaning more active as they were younger and less active as they were older. Okay, which of the following statements is an appropriate conclusion? I'm just going to tell you first, the correct answer is D. In general, you can only generalize to the largest like area or place or thing that you selected the participants from. And that's assuming that you randomly selected them, which I believe is, it's what was listed in the question. So the point being, and I'll get to this a little bit more, I talk about point C, you can't take any results from the study and generalize it to like other guinea pigs in a different country, or even if even in a different part of the country, or a different habitat nearby, or something. You can only generalize it to the overall like area or thing that you chose the guinea pigs from. Again, I'll talk about this a little bit more when I get to part C and showing why that's wrong. All right, so part A, this difference in behavior between the two age groups, meaning like one was older and one was differences between early adolescence and late adolescence, whatever, was caused by difference in habitat. There's no way of knowing that or proving that. Or the only way you would be able to determine this is if you somehow controlled for all of the other factors in the experiment and basically isolated it down to that one specific factor, the difference in habitat, causing this behavior, but there's no mention of that in there, so this does not make sense, whatsoever. Okay, part B. The difference in behavior between the two age groups was caused by aging. Okay, so meaning they get older, and as they get older, there's less movement or whatever. So yes, this is possible, but this is just correlation that they have noticed or observed. There is no proof of causation. And again, you would need to control for all the other variables or all the other factors to determine that the difference in behavior between early adolescence and late adolescence was caused solely by aging and not by, any other factor available. Like maybe during the study, I don't know, between when early adolescence started, into late adolescence, something happened with like the climate, and I don't know, it rained a lot, or it was the temperature got significantly colder or significantly warmer, or, whatever, and like one of those, or there was a drought or something, whatever. Any of those things could have impacted the amount of movement um, between early adolescence and late adolescence. Okay, and that's not mentioned anywhere in the description or anything, so therefore B is not an appropriate conclusion. Okay, let's talk about answer choice C. So this is what I was mentioning earlier. Basically, excuse me. The difference. This is now comparing the difference between the different animals only in early adolescence. Like in other words, one crossed more squares in early adolescence, the cavies did, than the guinea pigs. Okay, and C is saying that this can be generalized to all guinea pigs and all cavies. You cannot do that. You can only generalize study results to the largest thing that you chose the participants from. So in this case, that is the habitats. You cannot generalize it to, like I said, all guinea pigs, um, you know, in the county or in the state or in the region or in the country or in the continent or, in the entire world or whatever. Because you didn't randomly select the participants from those larger areas, those larger groups of guinea pigs. It's another way to think about this. It might be easier to think about this in terms of, like, say, schools or a school district, right? So you want to do a study. You select, I don't know, 100 students at random from a school district. And then you go ahead and you complete the study and you find whatever it is you're studying. Something about homework, number of hours spent on homework, and like versus participation in sports or versus having a job or whatever you're studying. The results of that study can only, assuming that you randomly selected the students, can only be generalized to that school district from which all the participants were selected. You cannot generalize it to, say, maybe other high schools in the same school district or the same county. You cannot generalize it to other high schools, maybe in the same city that are not in the same school district, or other high schools even in the same state, or all other high schools in the, United States in general. You cannot do that. You can only generalize it to the basically largest population from which the participants were selected at random. So the correct answer to this one is going to be letter D. All right, top of the next page. Let's look at question number 10 here. This is a unit circle question. I think there was one that was very, very similar to this a while ago, sometime last year, 2024. But I wanted to bring this up just to highlight it again and talk about a couple quick and easy methods to solve this. Okay, first method that I would do here. First approach, actually here's the quickest, shortest, easiest way, honestly, to do this. And then I'll talk about the theoretical way. Okay, this is root 3 over 3. So if you take the tangent of each of these angles, if it's equal to that decimal, then yes, it could be part of our answer. If it is not equal to that, then it is not part of that answer. So let's just type them in and see, do we get the same number for 1? Yes. Check it off. Now let's check 2. Get rid of this. No, we do not get the same answer. It's the opposite, actually. It's negative. Okay, get rid of that. Let's check 3. Do we get the same answer? Yes, we do. Therefore, correct answer is 1 and 3 only. So we have letter C, and that's it. That is the quickest, fastest, easiest way to solve it. I'll talk now about a theoretical approach to doing this, just if you're interested. So what I noticed is I went to Desmos and I said, okay, if I wanted to solve for this angle, angle A would equal arctan or inverse tan of root 3 over 3, right? So that's how many radians angle A is. That's basically the quadrant 1 reference angle. And then I change this to degrees. The reason I changed this to degrees is because now I recognize it's 30 degrees, therefore, okay, it's pi over 6 radians. Like, that's, I mean, if you recognize 0.523598, whatever, is pi over 6, then you don't have to do this extra step. Okay. So the question here is, basically, if these are pi over 6 radians, if pi over 6 radians is our quadrant 1 reference angle, you know, which of these is equivalent to it? And you think about tangent, right? Think about ASTC. Tangent will be positive in quadrant 1 and quadrant 3. So if you have a quadrant 1 angle here, basically to find equivalent expressions for the tangent of that angle, you're basically going to go like around, you're going to go around pi radians to get to quadrant 3, and then you're going to go another pi radians to get back to quadrant 1. So in other words, it's like you have pi over 6 plus n pi radians, because you're adding 1 pi, then another pi, then another pi. So it's like 1 pi, then 2 pi, 3 pi, 4 pi, so on. And then so basically what I'm doing is, and then I'm saying what does n equal for each of these angles? If it's a whole number, then it should be equivalent to it. Because just notice, when I start in quadrant 1, when I add whole numbers, I go to 3. And then when I add another whole number, I go back to 1, and so on. So here's what you see happen. For angle number 1, so we basically got pi over 6 plus n pi tilde negative 65 pi over 6. Okay, n equals negative 11. That means it is equivalent to it because I took pi over 6 and I added, you know, an integer number of pi's, technically in the negative direction, to it. However, look at number 2. Let's say I change this to 119. Notice that here n is not a whole number, okay? N is 19.6, it's 19 2/3. So that tells me that this one is not equivalent to this pi over 6 reference angle. Therefore, it's not a possible answer. And notice with 3, here, n is 13. It's an integer value. Therefore, that confirms 3 could be the measure of angle A in radians. Again, that's longer than just typing them all out, but that's just kind of the theory behind this problem. All right, let's look next at number 11. So in this problem, you have a linear equation with two variables, x and y. N is some non-zero number, and it forms a system of equations with no solution with another line. Basically, you know, wants to know which of these answer choices along with the given line makes a system of equations with no solution, i.e. two parallel lines if you graph them out. So, excuse me. Of course, I'll show you how to do this in Desmos. It's going to be much quicker and easier in Desmos, but here's how you could do this by hand. So if you notice, first of all, negative 15n, negative 15 cancel out. So you just get 15x equals 15y, or in other words, 15s will, you know, divide out. You just get y equals x, which means the slope of this line is 1. Also notice the b value is 0. So we're looking for each of these lines, we're looking for slopes of 1 and b values of not 0. If the b value equaled 0 and the slope was 1, then it would be infinite solutions, not no solution, because it would be the same line. So I'm going to use a shortcut here, negative a over b for our slope. So for a, it's 4 over negative 4. Is that slope positive 1? Nope. Eliminate it. Wait. Sorry. Mistake. Back up. It is, sorry, negative from the formula, then positive 4 over b, which is negative 4. So this, yes, is equal to positive 1. Sorry, keep it for now. 2. Negative from the formula, 4 over 4. This is negative 1. Eliminate it. C. Notice that A and C are identical, so it's just the slope is going to be the same here. It's going to be positive 1, so we keep it. And then D, here, this is the same as B. It's going to be negative 1 for the slope, so we could eliminate that one. Now we have to check what's the B value. So notice here, B is your y-intercept value. How do you get the y-intercept? You let x equal 0. So for C, when you plug in 0 for x, notice that the y-intercept value will just be 0. Whereas up here, if you plug in 0 for x, the y-intercept value would technically be, let's see, we're going to divide by 4. Let me just also erase this just so it's clear. Sorry, divide by -4. So it is just going to be n. Okay, so as long as n is not 0 in some number, then our correct answer is going to be letter A. So let's get rid of all this. Let's circle this, and now I can show you how you could solve this entirely in Desmos, probably in a much quicker manner than what I was just doing here. So first line, let's graph it out. And we're going to have to add a slider for n. You can just set equal to 1, it doesn't matter. Answer choices now. So notice A appears to be parallel. Okay. B, move this over here. Okay, so let's look at these one at a time. B, clearly not parallel. Not no solution. There is a solution to these two. Okay, so that one is out. Notice this one is overlapping. This is infinite solution, so this is not no solution. So C is out. Notice here, D, okay, there is a solution. They do intersect. This is not no solution. Therefore, correct answer here is going to be letter A. And it doesn't change. You can move A to it. You can move N to whatever you want. It's still going to be parallel. It's only overlapping when it's 0, but we're told N is a non-zero constant. All right, let's look at number 12. Now, this one is very, very similar to multiple problems I've had that I've covered already in the past, but I wanted to go over this one just because the fact that it's a little bit different and the fact that there is a number here added onto the constant. Typically in the past, there has not been another number added onto the constant under the root. Okay, so you can still solve this the same way. If you wanted to do it by hand, which I'll show first, you would square both sides. Square root and squared cancel out. And on the right side, you get x squared minus 6x plus 9. Remember, you have to write this twice and then FOIL it out. And then if I combine everything on one side, I get x squared minus 7x, because I got to subtract x over, and then plus 9 minus 4 plus k. So it really turns into k plus 5. Just checking my work here. Okay, so now all we need to check is the discriminant, b squared minus 4ac. So it's negative 7 squared minus 4 times 1 times k plus 5. And we set that equal to 0 because we know there's basically at least, one real solution. So now we go ahead and we simplify this. 49. Okay, this is just negative 4, so minus 4k minus 20 equals 0. 29 equals 4k. K equals 29 over 4. Or 7.25 as a fraction. All right, so that should be our answer. Let's just go to Desmos to confirm. Okay, so what I'm going to do is go to Desmos. First of all, clear out all this. The easiest way I know to check this is just type in the two graphs and see how many times they intersect. So, for example, notice here they are intersecting at one point. We can zoom in right here. It's this clickable point right here. Okay. It also says, has at least one real solution. What's the greatest possible value? So what happens if I try to increase this value? Now the problem is, technically, if I want the slider to appear, I have to type it as a decimal. Now, so notice when I increase it, notice there are no real solutions, meaning there is no longer at least one real solution. Like, the ceiling that you get to that still allows at least one real solution is the 7.25, okay? And that's it. So you can that just confirms that that is basically going to be the correct answer here. You can go smaller than it, obviously. That's like your, that's your floor. But for your ceiling, your greatest possible value, it's going to be that 7.25. All right, now let's see how you can do the entire problem in Desmos. So, first step, what we have to do is turn this into a quadratic. All right, so we're still going to square both sides. And then we are going to get everything equal to, actually no, what we're going to do, okay, there's multiple ways you could do this, I guess. I'm just thinking about, you're going to square both sides. Okay, so we're going to have x minus 3 squared, and we're also going to have x minus k plus 4. We want at least one real solution, so that means we want one intersection point. Okay, I guess I'll show two different ways you could do this. Method 1, which should be the quicker way, is to graph both functions. One of them is f of x, one of them is g of x. This is going to be called the derivative method. Okay, if you want to know more about this method, how it works, why it works, check out my Ultimate Desmos Guide to Digital SAT Math. I'll put on the screen a specific thumbnail for the video which covers this method and how to use it. So basically, it's finding the intersection point of these two functions such that they only intersect once. And notice it gives me the value of k is 7.25. And now what you could do is technically, if I just manually made k 7.3, notice they don't actually intersect. You might have to zoom in to see it here, but notice there's no intersection anymore. Okay? So that just confirms 7.25 is your floor. So this is the fastest way. It's the, again, the derivative method approach. Here is the vertex regression approach. So first step is the same. You square both sides. Second step, get everything into one function. So in other words, pull everything over to one side equal to 0. So I'm going to have this now, and I'm going to type a regression statement. And then this is going to be regressed to a vertex form quadratic, but with the k value, meaning the y-coordinate of the vertex, equal to 0. Let's add an element list. There we go. Perfect. Notice it's given us the same k value of 7.25. It does not graph the functions on this one, so that is one of the advantages to using the derivative method. But this method can be useful as well. Again, this is called like the vertex method. If you want more information on how this works, check out my Ultimate Desmos Guide to Digital SAT Math, and I will put a thumbnail on the screen showing you which specific video covers this. Next up, we have question number 13 at the top of the next page, and this problem is really just a basic linear regression, linear function problem. Like essentially what we have going on here is x and y values. The x value, you could use the year, or you could use, like, for example, the number of years since the year 2000. The y value is just going to be the two prices, $40 and $48.40. So you could either make these like 0 and 2, or you could technically use, 2000 and 2002. It doesn't matter, because when you go to calculate the slope, when you subtract them, you're going to get, regardless of what you use, even if you use 2002 and 2000, you're going to get a 2 for the change in x, and you're going to get 840 for the change in y, which means that we get $4.20 for the change per year, or essentially for the slope value. So now technically you can find the equation, but really all you have to do at this point is take the starting price, $40, right? Add to that the price in 2005. So that's 5 years. So that means we're adding 5 times $4.20. In other words, we're basically going to go through 5 increases, each of which is $4.20. So you just go ahead and work this out, and it should come out to $61. Let's just confirm that in Desmos, and then I'll show you how to do the entire problem in Desmos. And right there, 40 plus 5 times 4.20. Okay, now, if you want to do the entire problem in Desmos, of course, we can do this quite easily. Let us add a table. And again, for the points, it doesn't matter what you use for your x values. You can use 0 and 2, and I'll show you. Now, at this point, you technically could click on the linear regression button if you wanted to. Now, what you're trying to figure out is basically what's the value when x equals 5, okay? So there's multiple ways you could do this. At this point, you could technically type x equals 5 and look for the intersection. Okay, it's 61. You could also do 4.2 times 5 plus 40. That's what I typed, like in the, when I was doing it manually to get the answer. Let me just slide this up and we can see it's 61. And also just to show you one other thing, if I change each of these to 2000 and 2002, notice technically for the equation the b value changes, but the slope is the same. And the calculation now, what you would actually want to do is you would want to take this line. So if you're finding out when x equals 5, first of all, if you do x equals 5, it's going to be, should see here. We should see it. Why do we not see, here's x equals 5. Why are we not seeing the line graphed here? Oh, just realized that's the issue. It's technically, now you're technically not plugging in x equals 5. If you use this approach, you would technically be plugging in 2005. Okay, so you'd have to like zoom way out here. Okay, there it is, and then it's like way over here. There's the intersection point, 2005, 61. So you could do it that way, or if you're doing the same approach, 2005 minus 8360, notice we get 61. So you can technically use either way, but I think the easier way would be just to make this 0 and 2. In other words, your x is representing the number of years since the year 2000. Then you're just finding the x value for 5. All right. Let's go ahead and look at the next problem below this, number 14. So this was a problem, or there was a problem I came across. Someone mentioned about being given a quadratic function, and I wanted to know which of the forms in the answer choices displayed the x-intercepts as a constant or coefficient. All right, so if you recognize these various forms, you probably recognize that this is vertex form. This is just the original thing that you're given, which is standard form. Down here, you have intercept, or it's also sometimes called factored form. And then this is just whatever. There's no name for this. This is just some other random form. So it's basically, by process of elimination, it has to be essentially letter C. That's the only one that's going to have the x-intercepts in it. But here's how we could also use Desmos to solve this or to check it. What you would want to do is graph the original function. Okay, let me just go back to okay, what are my x-intercepts? -4 and +5. So I'm looking for a function which has those two values in it, -4 and +5. Now, the thing that might be a little bit confusing is that here you see -5 and +4, but technically we can say, just that this 5 is a constant. We can say that this really could be rewritten as x minus -4, and then that -4 is a constant. So therefore, C is the only one that meets the criteria that displays the x-intercepts either as a constant or coefficient. All right, let's look at the next problem at the bottom of the page, number 15. This one deals with lines. Oops. So you're given an equation of a line, and you're told that line M is perpendicular to it. You're also told line M passes through these 2 points. So these 2 points right here are both on line M. Wants to know the value of t. Okay, very quick and easy problem to solve. First, I'm going to take this given line, going to rewrite in slope-intercept form, which is just negative 3x minus 20. So therefore, my slope of this given line is negative 3, right here. Therefore, the slope of line M, so line M slope, line M, is going to be the opposite reciprocal of that, which means we take the negative 3 and we flip it to make 1/3, and we flip its sign from negative to positive. So line M has a slope of positive 1/3. Notice also this point right here, 0, 0, this is your b value because this is the origin. That means the y-intercept for this graph is going to be 0, 0, therefore b is 0. So the equation of line M is y equals 1/3 x plus 0. Now, when looking at the second point, when x is 12, what is the y value? Well, 1/3 times 12 plus 0, 1/3 times 12 is 4. 4 plus 0 equals 4. That is your value for t. That's what you would type in. Now, of course, you could do the entire problem in Desmos. So first thing I would do is, you could technically, I guess, really the easiest way to do this is to just first figure out or realize that the slope of this line is negative 3, and therefore you want the opposite reciprocal of that. So meaning once you know that, then you can put in the points, and you only need the 0, 0 because I'm going to type the linear regression because I know the slope is 1/3. Now, once I have that, I need to find where is the point 12 comma something. So multiple ways you could do this. You could do x equals 12, look at the intersection. Okay, it's right here at 4. That's our answer. Or we could just do 1/3 times 12. It's 4. That's our answer. So 2 ways to basically do that. However, there is an alternate approach that you could take using lists, which would actually get the value of t in only one step. So what I would do, and I'm just going to pretend this is like I'm doing this from scratch. We're going to do this is linear regression with lists, by the way. I will put a thumbnail on the screen showing you a specific video in my Ultimate Desmos guide, which covers this. This is what you have to do if you have a point value which has a constant in it. You cannot use a table unless you're then going to later use a slider to define the value of the constant of the letter. All right, so I'm going to make an element list for x1, so my 2 x points are 0 and 12, right? My 2 y points, this is for line M, are 0 and t. Then I do my regression. I know the slope is 1/3. And notice it automatically figures out the value of t right here as 4, or you can see it down here in the regression statement. So if you wanted to just do everything all in one step and get the answer right away, this is how you could do it and get 4. All right, let's move to the top of the next page. Question number 16. This is another line question, and specifically perpendicular lines again. Similar to the last one, but not quite the same. So you have line A, you have 2 points for line A. You have line B, you have 1 point. They say the origin, but we know that's 0, 0. And we know it's perpendicular to line A. These 2 lines intersect at some other random point PQ. What is P? All right, so first I will go through the general approach by hand. Then I will show you how to use how to solve the entire problem in Desmos. So step 1, let's find, so I'm going to do line A up here and line B down here. Okay, slope of line A. Well, it's going to be 4 minus 0 over 0 minus 5. Therefore, it is negative 4/5. Okay, what is the slope of line B? Well, it's the opposite reciprocal of that, so it's going to be positive 5/4. All right, so now, let me just look. at my work here for a second, we know that line A will have also, a B value of 4, because this right here is a y-intercept point, 0 comma something. All right, so that means we know now the equation for line A is negative 4/5 x plus 4. All right, next, line B goes through the origin. Okay, the origin is always a y-intercept value because it has an x value of 0. Therefore, we know that the b value for line B is 0. Let me just draw some columns here separating these. Therefore, the equation for line B is going to be y equals 5/4 x, technically plus 0, but I'm just not going to write that. Okay, these two lines intersect at the point P comma Q. What is the value of P? So, to find where these intersect, I'm just going to set them equal to each other and solve it. However, even if, I could go ahead and do this by hand, but instead I'm really just going to go to Desmos to find even just this part of it, because I think it's so much quicker to solve generally to solve systems of equations just by graphing them in Desmos. Now the problem is, which we'll see in a second, okay, so here's the intersection point. So P is the y coordinate, so that's all we're concerned with. So let me just get rid of the y, or the x, get rid of the y value. We only want the x value. Okay, so it looks like our answer is going to be, in decimal form, 1.951. So you could fill that in, 1.951. That's one acceptable answer. Now, if you do this approach, you won't be able to get what the fractional or exact value is. So I will just show you a way you could do that is instead to solve the system of equations using regression. So I'm just going to go ahead and put y1 tilde y1 the left side of both equations. Okay, in other words, both equations right here. And then the right side, so this is the top equation, and the bottom one should have been positive 5/4 x1. Okay, so notice here it gave me x1. So now if I type x1, notice it's, kind of the same, value, 1.95119, but this is, this is rounded off. However, when I click this, I get 80/41. That's the exact value, so you could also fill in that as well. 80/41, acceptable, correct answer. However, let's say you want to do the entire problem in Desmos, so let's go through that quickly here. Delete all this. Okay. So line A. I know it's 2 points. I would type the 2 points in a table, and then I would do linear regression. All right, that is the equation of line A. Now, for line B, I know a point, 0, 0, and see if this works. If I do -1/m x2 plus b. Yes, that did work. It carried over. Notice no, it did not work. Why did it work? It worked initially, but then something just changed and it did not work. So here's what I have to do. I'm just gonna have to manually take the slope here. I'm just gonna have to replace m with what it gave me from the initial regression and change it to -0.8. All right, now there is my line. There is line B. It's the same color, but all we're concerned with is where do they intersect. Okay, so it's this point right here, and again, I'm only concerned with the x-coordinate value, or letter P in the problem, 1.951. That is your answer. That's how you could do the entire problem in Desmos in about, 30 to 45 seconds. All right, let's look at the next problem now, number 17. We have a factoring problem. So when you see these 4-term problems, typically these are not just, at least these advanced ones, these are not factoring by grouping problems, meaning where like you group the first two and you group the last two, pull out a GCF, and then combine everything. Instead, typically the way you factor it is you have to group the first three or the last three and factor that as some type of trinomial, and then after that, you typically end up factoring as like a sum or difference of squares. So in this case, what's going to happen is we're actually going to group the first three, and this is going to factor as a perfect square trinomial. It's going to be x squared plus 3a times x squared plus 3a. And you can just multiply this out to confirm, x squared, x to the fourth. 3ax squared plus 3ax squared is just 6a x squared, and then the last 3a times 3a, 9a squared. However, I'm going to write it like this, and then I have the minus 16. Now it factors as a perfect square trinomial. So I'm going to get x squared plus 3a plus 4, x squared plus 3a minus 4. So what do I see over here? Okay, here I see x squared minus 3a minus 4. No, these both have plus 3a, so that's wrong. Next, x squared plus 3a minus 4. Okay, I see that right here, so this is probably the correct answer. X squared minus 3a. Okay, again, none of these have minus 3a's. X squared plus 3a. This has a 16 instead of a 4. Okay, that's wrong. So the correct answer is going to be letter B. Now, an alternate approach that you could try on this one, and I will say that there's a caveat that I think depending on the answer choices, this method may not work exclusively. You can graph the original problem. Okay, then you have to add a slider for a. You're going to be looking at the x-intercepts here. All right, and then what we're going to be doing is graphing out the various factors. And we're looking for the factor which has the same x-intercepts, or the same zeros. Because if something's a factor of the original, like, the original is going to have whatever, 2 or say 4, zeros, x-intercepts, roots, solutions, whatever you want to call them. One of the factors will have those same values, at least one of the same values as the original one does. Whoops, this was typed wrong. This should be this. Okay. X squared minus 3a minus 4. Okay, notice this one does not have the same x-intercepts. This is answer choice A as the original, therefore it cannot be the correct answer. Notice this B1 does have the same x-intercept values. Let's look at this one here. This one does not. Oh, I need to change this to plus. This one does not have the same x-intercept values, therefore cannot be a factor. And this one does not. I mean, basically, this one doesn't have any x-intercepts. Yeah, see, it's like way up here. Okay, so this is an approach you could take for this specific problem that could help you also determine the answers B. The problem or the limitation with this, I believe, is that if the original function itself, let's say, doesn't have any real solutions, or meaning it doesn't have any x-intercepts, in other words, then you're not going to be able to take this approach. Or the other possibility is that, like, maybe the original one does have x-intercept values, does have some real solutions, but all the factor choices that you're given as possible answers don't. Because notice when you graph the original one, right, the red one, notice it only crosses twice. There's only 2 real solutions to this. That's because the other one's going to have basically 2 complex, basically imaginary numbers, and 2 complex solutions. So the point is, if the factor was one that had 2 imaginary solutions, then if all the factors, all the answer choices were the ones with the imaginary solutions, then you wouldn't be able to match it up by matching the x-intercepts. I believe that is the limitation on, say, using this method. But if you have more experience with this or have other thoughts, please leave them in the comment section below, because haven't used this method a lot. This is not, part of my ultimate Desmos guide. It's only, basically looked at it for like a handful of factoring problems. Okay, very last question now on this worksheet of new problems from December 2025. Question number 18. You're given an exponential function here. X represents the number of years since the account was opened. F of x, of course, just represents how much money's in the account. And it basically wants to know, like, which of these statements describes essentially the percentage increase in the money accurately. Okay, so you can do this in Desmos to check. I'll show you just how to do that, calculating percentage increase. The theoretical perspective is, okay, we take this number, right, this 1.005. This is exponential growth, so it's like 1 plus r. That means the r value is 0.005. That's the decimal equivalent of it, but as a percentage, r would be, you multiply it by 100, it would be 0.5%. Okay? So this is increasing by 0.5%, the amount of money in the account, every some time period. That's what we're going to figure out. So the point is A is wrong, right off the bat. Okay, because it has 0.005%. No, there would be like 2 more zeros in here if that was the case. All right, so we know it's 0.5%. The question is, how frequently does this happen? So essentially, you have 1.005 times 2 times something. All right, let's look at answer choice B. So if it's every 6 years, that means you would plug in 6 for this, for x, which means the exponent would then become 12, which means the $6,000, the original amount, is increasing by 1.005 to the 12th, which is some number larger than 1.005. That means the amount of money is not increasing by 0.5%, it's increasing by some, other slightly larger amount. So B is going to be wrong. Essentially, if we want a 0.5% increase, which is what all the answer choices we're left with are talking about, we need this. Basically, we need to be left with 1.005, and we need this whole exponent to equal 1. Okay? So 2 times something, this whole thing needs to be equal to a 1. How do we do that? Well, this has to be basically 1/2 or 0.5. But remember, this number represents the number of years, not the number of months. So in other words, if I'm plugging in 1/2, like in other words, half of a year, that is equal to 6 months. Now again, you wouldn't plug in 6, you'd plug in technically like 6 over 12 to convert months to years. So the correct answer for this one, it's going to be letter D. It increases by 0.5% every 6 months because 2 times 1/2, which is the year, the way you represent 6 months in terms of a year, 1/2 of a year, will cancel out. It'll make this a 1, and then you're just multiplying the 6,000 by 1.005 to the first, which is just 1.005. Okay, let me show you just how you could confirm this now in Desmos. So, percentage increase, the formula, the way you calculate it, it's basically new minus old over old, and then times 100 just to convert it to a percentage. So if we go back to Desmos now, what I'm going to do is just enter the function. Okay, and now I'm going to find, so for the first one, I'm going to find how much it increased over that time period. So f of, and now here's again we have to be careful. It says 6 months, but again, we're not plugging in months for x, we're plugging in years. So like, I'm going to take the 6, I'm going to divide it by 12 to get the number of years. Minus, and I'm just going to use like 0 months as my, old. And then divide that initially, multiply that by 100. So notice, when I plug in 6 months, i.e. 6 over 12, for x, I get a 0.5% increase. That corresponds right here to letter D. It does not correspond to letter A. And now what I could also do, I mean, you don't need to do this, but just to show you, for B and C, if I tried to plug in those values, so for B, I'm just plugging in just the number 6 because it's 6 years. Okay? Well, it's not a 0.5% increase. After 6 years, it's a 6.16 or 6.17% increase, so that's wrong. Now, if you wanted to do 0.5 months, basically you have 0.5 and then divide that by 12. Okay, this is like some ridiculously small 0.04 to 0.041% increase, not 0.5%. So both of these again are wrong. That's how you could confirm this. Just basically solve the problem entirely in Desmos. All right, so I hope you enjoyed this first, well, really only December 2025 official problem set video with new problems. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, if you have questions or comments or alternate solution methods to any of these problems, please do leave them in the comments section below. Also, check out the second video of December 2025 problems, which is basically where I'm going to highlight all of the repeat problems that appeared on this December test that I've covered in previous videos. Related to that, also check out my official test problem set playlist, which has both new and repeat problems from all the other official test months, going back all the way to May of 2024. We're up to just under, with these 18 problems, we're up to just under 400 problems. I think I'm technically at like 388 or so total problems. And lastly, if you're looking to improve your knowledge of Desmos to help ace the digital SAT math section, please check out my ultimate Desmos guide to digital SAT math. It is now over 6 hours of tips and tricks and instruction and 65 practice problems to help you learn Desmos and ace the digital SAT math section.